Okay, hello everybody. My name is Matthias Sohn. I'm working for SAP, and I'm also leading the Git project together with Sean Pierce from Google. And we are also contributing to Gerrit, and that's why we frequently do Git tutorials. Let's just jump into what we will be doing today. First, I have short introductions, a few slides, and the main part of this tutorial will be, of course, exercises. You can try out a lot of stuff. I will also show some of the exercises so that you don't have to read all the detailed descriptions. And if you don't manage to do all the exercises, don't mind, you can also continue them later. So you have all the software on a stick, so you can run your own Gerrit instance locally, so you can also continue later. And if you already know the basics, you can also skip the basics and start with a later exercise. And then we'll have three main parts of the exercises. So the first one is, of course, setting up everything, a bit of configuration, and then you will clone the sample repository. And then in the first part, we do local development so that you learn how to use Git locally. In the second part, we will both learn how to push changes to a server and how to use Gerrit for code review. And of course, if you have questions, you can ask anytime, and Michael can also help if there are questions. So first, what is Git? Mainly it's a version control system. It's a distributed one, so every developer has a copy of the repository, so you have the history locally, so most of the commands are executed locally, which is of course good for scalability, and you can also do most of the stuff you can also do offline. It was started by Linus Torvalds himself. They lost the license for BitKeeper they used before for the Linux kernel. So he started a new versioning system because he didn't like the other ones which were available in open source. And the main part, the main feature of Git is that it doesn't enforce a specific workflow, so you can't choose workflows like you want. If you're using Gerrit code, you have the Gerrit system as a Git server. It imposes a workflow, but I think it's really a very nice one. But if you use Git, you can also do other workflows. Now let's have a look at Git usage at Eclipse. So the JGit and eGit projects moved to Eclipse in 2009, and of course they were already using Git. So they were the first projects to use Git at Eclipse. So we got an exception that we don't have to move to CVS. In 2010 we started to also introduce Gerrit. So we were also the front runners for Gerrit at Eclipse. And since 2011, all the Eclipse projects started moving to Git because a plan was set up to get rid of CVS and also Subversion. So end of 2013, CVS support ended. So the only project which is still in CVS is Orbit because it has a lot of binary content, which is not really the right content for Git because, I mean, if you clone the repository to every developer and it's a very large one, this would be a pain. But for source code, Git of course has a lot of advantages. Also since beginning of 2013, Gerrit is available to all Eclipse projects. So many projects use it to get contributions. It facilitates contributing to a project where you don't have the committer permissions. Now let's look at development with Git if you're using Eclipse. So you want to have an integrated Git UI inside Eclipse, so you don't have to jump out to the command line. I mean, I know there are still many developers using Git on the command line and doing their development in Eclipse. I also do it from time to time. This is the typical setup if you're using Gerrit as the server. So Gerrit is hosting a lot of Git repositories at Eclipse, I don't know, 100 or something like that. And on your local PC, you install Eclipse with eGit. So you have Git integration in Eclipse. If you want, you can also install native Git, but it's not required anymore because eGit almost covers everything. I mean, some of the very advanced stuff is not yet available, but you don't need that frequently. And then you clone those repositories you want to work on, and you can version locally because it's a distributed versioning system. And when a change is ready and you want to share it with the team, you push it up to the server because the server is always online and it's visible from all the networks. I mean, usually your developer PC isn't visible outside your company network, for example. So that's the reason why still typically there's some central Git server where you exchange changes between developers working on the same team. We have a small sample application. It's a very simple one. So it's a calculator, and during the exercises you can add new operations. It's very easy. Just you can simply copy one of the operations and modify that. Or of course you can also tweak anything else. Now I will show first how the setup works. And I'll also show how to clone the example repository. And then we will first try out how to do local development. Just create a feature, implement a feature, a small one, implement another one on a different branch so that you can see it's very easy to jump between branches. And then we'll see how to continue. So on the stick, in the tutorial folder, first of all, in order to have access to a server, there are two choices. If you already have an Eclipse account, you can use that and clone the sample repository from the Gerrit server running at Eclipse. So in the first exercise, it's described how to do that. The other option is you can run your own Gerrit system. Just unpack the zip file. So you get a folder which contains the Gerrit installation, and it also contains the sample project called Is Git training, and it also has, if you want to look at a more complex history, it also has a copy of the JGit and the Is Git repositories. In order to start that, you just cd to the Gerrit site folder. So Git tutorial demo Gerrit site, I think. Okay, and you just run java -jar bin Gerrit war and then daemon. That's the command to start the daemon. And then you have to give the directory where it finds the root folder of the installation. So if you started from the top level folder Gerrit site, it's just this folder. There are also startup scripts if you want to run that as a service, but we skip that for the tutorial. There comes some warning, but that shouldn't harm. If you happen to run something else on port 8080, you can change the port number in the EDC folder. There's a Gerrit config file, and you can change the port number here, and then you have to restart the server. Then it will run on a different port. If you want to use the server at Eclipse and you don't have an account yet, I would advise you use the local one. But of course, you can also get an account at Eclipse if you also plan to contribute to some Eclipse projects. This makes sense. So in the first exercise description, it's also described how to register a new account. So that's a page where you get the new account. And there's another page where you have to electronically sign a contribution license agreement. Maybe you can't do that, so for that case, you can also use a local Gerrit instance, which doesn't have these restrictions. Okay, now we have a Gerrit server running. The other thing we need is an Eclipse installation. So we have it on a stick. So I just unpack that here. Just choose the folder of your operating system and unpack the Eclipse package. It contains also the latest Git version, which will be released next week with Luna. It's technically already ready. And then you can start Eclipse from here. The name of this depends on your platform. And then choose some workspace name. Okay, there was something in that one already, so I delete that one. Okay, now we are all set. You can also check if you, here's the Git configuration under team. And you should check that for the user settings, you need to configure your username, your name. So it's, for me, it's Matthias Sohn, and your email address you will use with Gerrit or with Git. So it's this one. The name is just convenient so that your colleagues can see who did that change. And the email address is in Git is the identification of a user. And in productive servers, the email address is checked against the user who is logged on. On the demo server, you can use any email address, so there's no check, but on productive servers, it will be checked so that you can't use an email address of a different user, for example. So if you're doing the exercises against the Eclipse server, you have to use the email address you registered with your Eclipse account. Okay, and let's have a look at the server. So just, if you're using the local one, go to localhost 8080. And this is running in development mode, so you don't have to log on. You can simply become a user, and there are already 3 users. There's an admin if you want to play with the configuration. I won't cover that during this tutorial, but you can try. And there are 2 developers, A developer and B developer. And if you want to see the settings of this developer, just click on the right top. You see the settings. And here you see the username you have to use for the Git operations. And under HTTP password, you see a generated password. It's already there in the shrink-wrapped Gerrit, so you don't have to generate a new one. If you want, you can of course change it. And these credentials you have to use if you're pushing changes to this Gerrit system. And if you want to find the URL of the sample repository, just navigate to projects list, and then click on the training project, and here you see the URL, which you can use to clone the repository. So let's just do that. I advise that you open the Git repositories view and the staging view in eGit because they are really used frequently, so it makes sense to open them in a perspective where you do development. So don't use the Git perspective, it's just for looking at Git, but if you're really planning to work with Git, it makes sense to open these views, the repositories view and the staging view in the perspective where you're doing the development. So in this case, it's Java development. So let's clone the repository. And here we now give these credentials of the local system. So let's have a look again. What was this? HTTP password. So we take developer 01 and this password. And then you just press next, and it will show the branches available on the server. For this project, there's only the master branch. On real projects, you typically have some maintenance branches for already existing releases. And here you can choose where to store the local copy of the repository, which you will use for most of the operations. And if you check this one, also the contained Eclipse projects will be immediately imported. Okay, that's a problem on Mac. I found that with this version of Eclipse, you have to switch off the key chain integration, otherwise this storing in secure store doesn't work. We can fix that here. If you go to the UL, you can later on change the credentials. And here it asks for the secure store password to generate a new one. Now we can enter this again. I think that's fixed in later versions of Eclipse. Okay, now we got a copy of the repository. Next step is probably looking at the history. So let's show this, the history of this project. Be aware of the toggle buttons in the history view. There are a lot of toggle buttons. Most of them are only active if you select some resources. So if you select the repository, some of them are inactive. I recommend that you press this one to link it with a selection. Then the history will follow what you select. I recommend to, in the beginning at least, select show all changes in the repository so that the shown history isn't filtered with your selection. And you should also check the show all branches button, because then you will see all the branches. As soon as you work with more than one branch, it might make sense to filter out everything which can't be seen from the current branch, but in the beginning it makes sense to always see all the branches, then you see what you're doing. So, and if you now happen to select some class, for example, you can try out these buttons here. So if you select this one, you only see the change, the commits which touched this file. And if you go back to this one, you see all the commits in the history of this project. Now let's run the sample application. There are some launch configurations to run it. And here we have it. Very nice calculator. And you can do some complicated calculations. It seems to work. There are also some small tests. So if you want to try that, you can simply run here all tests, launch configuration, and then it will run the tests. Okay, and now in the first two exercises, you will be adding 2 operations, for example. So the easiest way to do that is just copy an existing one and paste it with a different name if you're lazy. So let's try divide. And the other thing you should do, if you're working with Git, it makes sense to create a new local branch for every new stuff you're doing. So if you're creating a new feature A, create a branch which is called like the feature. If you're creating another one in parallel, create another branch so you can keep them separate. So let's just create a branch for divide. The branches are these little green boxes. The green ones are the local branches, so they move when you create a new commit. And the gray ones are so-called remote tracking branches. They are proxies for branches on the server so that you can see what's the state on the server. Of course, this might be outdated. If it's outdated, you simply run fetch from upstream and you will get all the updates from the server, and only the gray branches, the remote tracking branches, will move then. Okay, we added a divide class. Now we have to implement it, so we have to simply tweak that. I copied the plus operation. And then in addition, I have to register that. There's a calculator class where you have to register the new operation. Just in the setup default operations, call the constructor of the new command. And then we should be set. And then we can run this. And now we have a new operation. So we can do divisions. 5 divided by 2. 2.5 seems to work. Okay, so let's commit the first version. So we go to the staging view, It's more, there's also a commit dialog, but it's a modal dialog, so you have to create the commit in one go. With Git, you typically work in iterations. There's a so-called staging area or index where you can put in those changes you want to have in the next commit. And in the staging view, you can do this iteratively. So you could first add just the new class for division, and then you do the registration and the calculator, and later on you also add this one. And of course, you can also revert this decision. And this will have the effect that this version of the file is already put in the database, and the index keeps a pointer of to that version so that you can move back and forth without changing the file system state. And then we can create a commit. Before we do that, we first configure for Gerrit, because Gerrit requires that the commit contains a so-called change ID in order to enable that you can do iterations on a change. So it needs some identity which makes it possible to find out which commits are iterations of the same change. And for that, you have to generate a change ID and do a little configuration. So we just go to this remote, which points to the server where we cloned the repository from, and do the Gerrit configuration here. And the only thing you have to do, if it's not already there, you have to add the user ID. And this is the branch you will be later on in the second half of the exercises pushing changes for review to. Okay. And now you see you get a little green decorator, and you also get some new menus on the repository. You only get these Gerrit menus if you configure the repository to work with Gerrit, so that these menus don't disturb guys who don't use Gerrit. And you also see that after this configuration, the commit message already gets automatically a change ID, because that's required for Gerrit, so you don't have to do that manually. And if you're pushing changes to the Eclipse server, you also have to sign off every commit. Signing off means you simply add another footer, signed off by, and then your Git identification, your name plus email address. And by this, you confirm that this commit will be contributed under the contribution license agreement of Eclipse. You'd only have to do that if you push changes to Eclipse. If you push it to the demo server, you can leave that out. And if you do that frequently, you can go to the preferences, and there you can also switch on that you always do the sign-off. Just check this checkbox here on the commit dialog, and then you will always get this. As we are now using the, I'm doing that now on the using the demo server, so I don't need to do that. And now I give a commit message, add divide operation, for example. And then I can simply commit, and let's see in the history what happened. So we added a new operation, and we did that on a feature branch called divide. And now we created a new commit in order to implement this new operation. And now the next task is to create another operation on a different branch, so that you can see you can jump back and forth between different features you're working on in parallel, which is especially interesting if you're doing code review, because code review takes time. And while you're waiting for review comments from your colleagues, you want to work on something else. And with Git, that's very easy, because you simply create another branch. So let's create the multiply branch, for example, to create another operation. This is immediately checked out. So the divide operation is gone now, because it sits on the other branch. And now we just create another new command, multiply. Again, we have to implement that one and register it in the calculator class. And you can also already guess what will happen with this registration. I mean, now I'm doing a change in the same place where I did it for the other operation. So later on you will get conflicts on this line. So that's on purpose. We could have done this in a different way so that it doesn't create conflicts, but you should learn how to handle them. So now we have a multiply operation. Again, we can commit that one. Add multi. Now I do a typo just to show you one more feature. Multiply operation. And we just commit that one. Look at the history to see what happened. Now we have two operations on two different feature branches. If you check out this one, the multiply branch, we see the multiply operation. If you check out the divide branch, we see the divide operation. So we can work independently on two different tasks or on 10 different tasks if you want. Just use different branches locally. Of course, later when you want to bring them together, this will be shown in the next round. Okay, now one more thing. If you did a typo like this, you just want to fix a little problem in the last commit on the branch you're on, you can simply amend the commit by going to the staging view and pressing this button, which says amend the previous commit, so you can immediately patch this one. So it doesn't create a new commit. It creates a new commit, but this one is replacing the previous one. It's not a successor of the previous one. So we can fix this here and just simply commit again. And now if you look at the history, the typo is fixed and the other commit is still there, but you don't see it because no branch is pointing at it. Okay, so I think now it's time for you to try that. There are instructions in the exercise descriptions, so you can try what I showed you. And in a few minutes we will continue with the next steps. So I think we should continue because we still have some stuff to cover. So at least some of you managed to clone the repository, run the server, do a little change, and maybe do a second change on another branch. So just some few words what you did when you created a commit. First of all, the storage of the repository. If you look in the directory where you cloned the repository, you will find the .git folder. This is the object database where Git stores all the versions. So this contains everything, the complete history of your project. And beneath that, you have the so-called working directory or working tree where you do changes in the file system using an editor or using Eclipse. And now there are two main operations you can use to transfer objects between the working directory and the repository and vice versa. So if you're checking out a branch, you're moving file versions from the repository to the working tree so that the working tree matches what you checked out from the repository. And the opposite operation is creating a commit. This will transfer objects into the database so that that they are added to the version history. In fact, there's this Git index in between so that you can create commits incrementally. That's not shown in this diagram. Now, what is a commit? Mainly a commit is logically, it's a pointer to a version of the complete tree, of the complete working directory, except those files you ignore. So you can tell Git, I don't want to check in class files, for example, which makes sense. So this points to the tree, the root directory of the working tree, and that points to contain folders and file versions. And then a commit contains an author and a committer, so there are two users. Most often, these two user entries are the same. If you're the only one changing that change, if someone else gets your change by Git transport and does some additional modifications, then the author will be the one who started the change, and the committer will be the one who last changed this commit. And of course, there's a commit message. And for the commit message, it's important to explain why you're doing the change. Because what you change, you can see from the technical diff. So if you just tell Git, show me the diff, then you see what was changed, but you don't know why. So the most important content of the message is to explain why you do this. Of course, you should also have a short description what you did. so that you can read the history later on. And then the commit has a SHA-1. All the objects in Git have SHA-1s, so secure hashes over the content. And this ensures that you can't tweak the database. So you can't tweak the history without anybody else noticing that you did so. So if you're trying to tweak the history, I mean, you have a local copy, so you could come to the idea to tweak the history to hide something, for example, or to change a password or whatever. This will break the referential integrity of the repository, and the repository will notice that. So if you run for example, if you run a garbage collector, it will break if you tweak the repository content. And there's also a command to check the integrity of the repository. So this ensures that the distributed versioning system still you can trust it, because you can't tweak the content of the database, because that will break all the references. And then in addition, of course, you want to form a history out of these commits. So each commit points to its parent commit, and this way the version graph is constructed. And if you have a merge commit, it will have more than one parent. So it's a pretty simple technical model which is underlying, which is used for the implementation. And just using the commit objects, the tree objects, and the blob objects is sufficient to work with Git. It's pretty hard to do that without branches, but it's possible. Now we add branches to this model. What is a branch in Git? It's just a name pointer to a commit, nothing more. So it's just a file containing a SHA-1 of the commit it points to. So it's a very simple thing. It's a local object, so it's never transported. So you can name your local branches like you want, because nobody else will see them. As soon as you start transporting changes between different repositories, you have to always give a mapping how to map local branches to remote branches. Of course, you can use a workflow where you map these branches one-to-one to the server. Then you would say git push to the URL of the repository or the remote name of the repository, and then you say master :master if you want to push your local master to the remote master branch. But you can also have a different mapping. And if you create a new commit, the current branch, in this example master, the one which is checked out, will move. So you put the new version in a commit object, and the branch pointer will advance. Only the local branches do that. Remote tracking branches don't change if you commit. They only change if you get new objects from the server. So there are two different types of branches in Git. Enough theory. Back to the exercises. So the next step will be trying to merge changes done on different branches and trying to rebase, and also learn how to resolve conflicts which may happen when you're doing these operations. So in the previous exercises, I created two operations on the multiply and on the divide operation, divide branch. And now we want to bring them together. Let's say we want to bring them into the master branch. So we first try that locally. Later on, of course, you want to have all these changes on the master branch on the server. But this is an additional step. So let's first try that locally. So we check out the local master branch. And now if you maybe want to first get the divide operation into the local master branch, we simply select the divide operation and say merge. In this case, Git says this was a fast forward merge, and the reason for that is there was no reason to create a new commit in order to bring this together, because the commit we are trying to merge is a successor of the master branch, so it can simply forward the pointer. There's no need to create another commit to bring together the changes done on different branches. So this is a very simple one. Happens frequently, of course. So if there's no concurrency, if you're the only one working on the project, that's a normal case. But if something happens, if multiple features are developed in parallel by different developers, for example, then of course you have to bring them together. And one way to do that is you merge the second operation. We merge that again, and now we get conflicts, as I already predicted earlier, because both changes did that registration at the same in the same place of this calculator class. So you can already see Git put some conflict markers into the file. We also do that in eGit in order to stay interoperable with native Git. Otherwise, this wouldn't be interoperable. But there's a different way to look on that in Eclipse. So you also see conflict markers here on the changed files in the staging view, which always shows you the Git status, so what you touched in your local working tree compared to the currently checked out branch. And it's also decorated in the package explorer, for example, so that you can easily find the place where you have to do something about this conflict. And the most convenient way to resolve this conflict is you start the merge tool, for example, from the staging view. Start the merge tool. And then you can either, by default, it will simply show the heads, so you will see both versions in two different screens, or you can choose to use the pre-merged stuff, which is already shown in the editor here. And now I maximize that one so that you can better see what's shown here. So the conflicting areas are marked in red. So let's directly jump there. So on one side, this is the divide operation branch, and this is the other branch, the multiply operation, and they changed the same line, so Git doesn't know what to do. In that case, you have to manually decide what you want. In Eclipse compare views, always the left-hand side is what is modifiable. So we want to add both. An easy way is to just click this little button here, so it will copy the change from the right side to the left side. If that's not what you want, you can directly edit here on the left-hand side. Just edit, remove what you don't like. Then we save that. It still shows it as conflicting because Git doesn't know that you're already finished resolving this conflict. You could need multiple steps to do this resolution. In order to declare this conflict to be resolved, you have to stage it. So you have to add it to the Git index, and this marks the conflict resolved. So you can either hit this add to Git index, or you just do drag and drop and move it to the staged changes. So now we have still a compilation warning because we miss an import. And we can fix that by just auto-fixing the import. Or we could have done, of course, the same in the merge tools. I just showed now the conflicting areas. There were some more changes we didn't take over. That's the reason why we lost this import statement. And now you see we did another change after staging the first change. So we have the calculator class both under unstaged changes and understaged changes. And if you want to see what we just did, just double click and you will see what we didn't yet stage. So this addition of the import statement is captured differently in addition. So if you also want to have this in the conflict resolution, we also have to stage that one. And now the staged change contains both of them. So the import statement and the conflict resolution over here. When you're creating a merge commit, Git automatically generates a commit message, and if there are conflicts, it also puts a note that there were conflicts. Usually, you erase them as soon as you resolve the conflicts, but you can also leave them. That's up to you. I typically remove them. And then, in order to finish this creation of a merge commit plus conflict resolution, you have to simply commit this change. And now if you look at the resulting history, we see that we now got a new commit, which brings together the changes which were done on two different branches. So this is one way to combine the work you do in parallel on different branches or on different computers in a team. If you're doing it in a team, it's a bit more complex because first you have to bring these changes onto the same copy of the repository, because different developers don't work on the same copy. So you first have to push them to the server, and from there the other developer can get the change, and then you can bring them together. Git helps in that because it also does server-side merges. If you're not using Git, you have to always do the merges locally. So you have to get all the changes you want to combine into your local copy, and then you can merge them. And then push the merge commit back to the server so that everybody else sees the result. You can also undo this operation if you don't like what happened. So you can simply move back this pointer to the previous version. And this is as simple as just running a hard reset. So just select the commit you want to move the current branch back, and we can undo the merge operation. I do that now because I also want to show you what's the difference to rebase operation, which does something else. So I now undo this merge operation by resetting to the multiply branch. This forcefully moves the master branch now to the multiply branch. And this way the merge commit is no longer visible because no branch is pointing at it. It's still in the database, but you can't see it anymore. And now we try the other operation, which can be used to combine changes done on different branches. This is useful if the change you're trying to bring in has to catch up what happened on the server, for example. So let's assume the master branch on the server moved to the multiply operation. Somebody else committed that to the server. You should never change commits which have already reached the public branch on the server, because that confuses all the other developers on the team, which may have based new changes on top of this. So don't do that. If it's already published on a public branch on the server, don't touch it anymore. Only if you have some catastrophic problem, then you may do it, but then you have to inform all the others. But if it's just local work, you can rewrite the history as you want. So let's assume the divide operation hasn't been shared yet on the server. Now we want to catch up with this multiply operation, which was already published on the server. Just let's assume that. I didn't do that yet, but let's assume it. So let's assume the origin master is already here on the multiply operation. Now I have the problem that I started the divide operation, but on an outdated base version. It's no longer the master on the server. I could now simply cherry pick this one to copy the single change on top of the master. But if you have a series of changes here, that would be tedious because you would have to repeat the cherry pick over and over again. And therefore Git has a rebase operation which allows to move a complete branch forward ported to the updated base version. So we check out this branch we want to rebase, and now we select the one we want to rebase on. So we want to move the base version of this commit, which was this one. We want to move it up to this one. So we select this one, and then we say rebase on. And now again, of course, we get the same conflict because both branches change the same line, so we have to again fix that. Just for demonstration, I choose now the other option here. This now has the effect that Git pre-merges what it can pre-merge, and where there are conflicts, it will put conflict markers directly into the text file. Now this looks like that. And this time you just remove the conflict markers because we want to have both lines in the result. The effect, of course, is in the end the same. And it's still marked as a conflict, so we have to declare the conflict is resolved by, again, staging this. And this time, since it's a rebase operation, you don't have to commit to proceed, but you have to continue. And the reason for that is that rebase is, in general, a multi-step process, because it may happen, if you move more than one commit, it may happen that you get more than one conflict. You can get a conflict for each of them in the worst case. Fortunately, this only happens in rare cases that you get more than one conflict. So you would simply say continue here, and then the rebase operation will finish. And if you look at the result, now we have again combined both operations, but we don't have a fork in the history anymore. We removed that fork by forward porting the divide branch. So the advantage of this one is, of course, it's later on it's easier to read this history because it looks like it was linear. You're cheating a bit. So in reality, you did it in parallel, but you can do away with that by using Rebase to linearize your history. And this makes it much easier to later on understand the history. So especially if you're using code review, this is the way to go. If you're not using code review but directly pushing to the server branch, you should only do it for changes which not have been shared with others on a public branch yet. So it's good for local branches, but don't do it for server-side branches. Okay, some short more words on the history view. I already explained that there are a few toggle buttons here. You should really try out these toggle buttons. For example, let's select this calculator class and see how we can filter history. So if we click this button, we only see those commits which touched the selection, so which touched the calculator class. If we select this one, we see all the changes which touched any file underneath the folder ahead on top of the selected class. And if we select this one, we see all the changes in the same Eclipse project. And if we select this one, we see all the changes in the repository. Any other important one is this one, link the history view with the selection. We don't do that by default because on large repositories it costs some performance, of course, constantly updating the history. But on reasonably sized repositories it shouldn't be a problem. Okay, that's it for this part. Now I have one more advanced feature I want to show. Don't know if you will be able to, can play with that. I prepared a situation where we want something more complex than just rebasing on a new base version, but we want to fix history because we did some mistakes when we did local development. And for that we can use, there's one way how you can fix such problems. You can use cherry pick to emulate interactive rebase, or you can use a real gun and use interactive rebase to fix your history. Again, only do this on changes which not have been shared on a public branch. So I prepared a little example here. So I added a divide operation. Then I noticed, okay, I missed to update the Java doc, so I did another commit because I missed to amend this commit. Then I implemented the multiply command, and then I added some ridiculous comment I later on want to get rid of. Then I noticed, okay, I missed to add tests for this implementation of the divide operation. So I added another commit, adding a test for that. And finally, I also added a test for the multiply operation. And now look at this history. It's really a mess. I don't want to share this with my team. I don't want to tell them that I'm such a silly guy doing such a silly zigzag line of changes. So I want to fix that before I change that with the rest of the world. And the easiest way to do that is to use interactive rebase, so you can really edit the history. Let's just do one more try. Let's run the tests. Maybe I did one more mistake. Let's see. Unfortunately, something is broken. Let's see what happened here. So the divide operation test is failing. So maybe the divide operation has a wrong implementation. Let's see. Let's open this version. Okay, can you spot the problem? I copied that from the minus operation and I forgot to implement the operation, so I got a minus operation, so the test is failing. So I want to fix that now. But how can I fix that? It's deep down in my history. So there's one way to how you can do it on the fly. So there's some shortcut operation where you can simply change one commit which is down in the history. It should be on top of any remote tracking branches so that you don't disturb your colleagues. If it's just local, then you can do that. So you just go there, go to modify, and click edit, and then you can edit this old commit which is down in the history. What will happen under the cover is Git will start configure an interactive rebase operation and immediately configure it in a way so that you can immediately fix the problem on the commit you want to edit. So I can now directly fix this problem here. Okay, I can't fix it in that because it's not the workspace version, it's the version from the database. So I have to first get this workspace version. And then I can modify that one. And then I can simply stage my fix. And you see that Git already pressed the amend button for me because it knows I want to edit this one, so I have to amend this commit. And the start of the interactive rebase command first prepares a list of actions I want to do on the commits I selected. Everything above the commit I selected is entered into that list, and then I can pick commands on these commits, what I want to do about this. And since I directly want to edit this one, it's already pre-configured. And if you edit a commit, you have to commit amend in order to replace the previous one. And so that you don't need to notice, Git already selected this checkbox or this toggle button automatically. So you just need to commit, and then you can continue the rebase operation, which will pick all the other changes on top of the modified one. And then you can see the result here. I maximize that one. So we fixed the divide operation, we amended this commit, and then Interactive Rebase copied all the other ones on top. I put another branch on this one so that you can still see the old history. If I wouldn't have done that, you wouldn't see the old one anymore. And now let's run the tests again. So if you now run them, hopefully the tests are green. You remember the tests were not in the commit where I added the operation, so I have to really rebase. Now we fixed this problem, but still the history looks ugly. So let's repeat this. And now we want to fix all the remaining problems in one go. So we configure the interactive rebase manually so that we don't have to repeat this over and over again. In order to do so, you select the commit the last commit you don't want to change. And then you say rebase interactive. This again prepares a rebase list containing all the commits which are above the one which you selected. And now we can see how we want to change that. First of all, we want to add the test in the same change where we added the implementation, because that makes sense. I mean, we want to qualify the new implementation immediately in the same change. So you want to move this one beneath the implementation of the operation, and we want to combine these two commits into one, so we squash. So put squash on if you select the action squash on a commit, it will be squashed with the previous one, which is on top of it. Then we also have fixed the Java doc here in another commit. We also want to squash that into the same change, so we put squash here again. So these two commits will be included into this one. Then here we have a typo, so we want to fix the typo in the commit message. You can do that by selecting reword. And this is a command I don't want anymore. I just added some command which is useless, so we can skip this commit. And again, here we have the multiply tests, And here is the implementation. So we want to put that in one commit. So let's move that up. And again, squash this one into that one. Now we prepared our wish list for the interactive rebase, and we can tell Git do the rest. And if you're lucky, we don't hit conflicts. In that case, probably we will. I don't know. Let's try. And now it's simply doing all these operations. And of course, sometimes there's some user interaction required. So here, we're combining 2 commit or 3 commits into one. And the open question is how to combine the commit messages. Therefore, an editor is opened where you can see the combined commit messages and decide how the final one should look like. So I just erase the 2 fix-up commit messages. And again, here we have a typo in the commit message, so we have to type something. And at the bottom in the interactive rebase view, you see at which commit we're currently where the operation stopped. Okay, then we're done with that one. And again, we are squashing here, this one into that one. So we have to decide how to combine these 2 commit messages. So let's again erase the second one. And finally, we are done. Hopefully the history looks better now. So we started with 1, 2, 3, 4, 5, 6 commits. And now we only have 2. And this looks much cleaner, right? So now we have divide operation, including tests and with the right Java doc. And we have the multiply operation with its tests. And we removed this command change we didn't want to have in the result. So that's the power tool to edit more than one change. If you only want to fix something in the last commit, use commit amend. And if you want to change a series of commits, use interactive rebase. So now it's up to you to try at least some part of that. There are also some other shortcuts. So for example, for squashing, you can simply select adjacent commits on the same, which are on the same line of descent. And then you can squash them directly from here. So you don't need to prepare this list, it's automatically prepared in that case. And you can also revert directly. There's another shortcut here, so you can directly revert a commit message in a commit which is down in the history. Okay, have fun, try it out. It's also in the exercises. So first, try merging and rebasing. And if there's still time, you can also try interactive rebase. Time is running fast. So I think I can only demonstrate the Garrett stuff. Okay, since we're running out of time, I at least want to shortly show what Garrett is. There's no time that you can really do these exercises, but you can of course continue later. You have your own instance now. So what is Garrett Code Review? It was started by Google for code review on the Android open source project. So there are tons of contributors to Android. Many other companies are contributing. And he wanted to have a review process so that contributions are easy to manage. Sorry, the title is a bit mangled. Garrett at Eclipse is enabled for most of the projects, so it's also the way to go if you want to contribute to some Eclipse project, because it's easier if you compare to the traditional contribution process. So what is Garrett? It's a Git server in the first place. That's that part we already used in the Git exercises. Then it adds access control, so it's possible to have different permissions for different roles, and you can also have a fine-grained control on which branch you can do what. It adds a code review workflow, and since 2 years or so, it also has a plugin API, so you can also add functionality on your own. The typical roles in a Garrett project are, there's an administrator, of course, who has full control. Then there are committers. They have the decision rights on the project. So for example, I am an eGit committer, so I have commit rights on the eGit project. There are reviewers. Typically, reviewers can be committers or contributors, of course. Contributors can also review changes done by other contributors, why not? But they can't take decisions. They can only give their opinion. Committers can take decisions. And then there are contributors. These are the previous guys who contribute fixes, for example, or some nice new features. Sometimes, of course, all these roles fall together. So committers, of course, are also reviewers and contributors. How does the review process look like? So contributors push their proposed changes into the review queue, which and Gerrit will then automatically generate a feature branch on the server side. Because you do the code review in Gerrit before a change reaches the target branch. So you want to put a change in master, so you first have to push it to the review queue for the master branch. And then some reviewers will come. They will read your code, comment on what you propose. They will also fetch this code and try it out locally to see if they can break it. Then they will comment. They can give votes. Is this a good change, or does it need improvement, or it's completely going in the wrong direction, so they want to veto the change. There's also an integration so that you can, for example, integrate Hudson or Jenkins so that the build job will be triggered when a new change is proposed in review. So the build server can vote on the compilability of the change, and it can run the tests. And if they are fine, it will vote positive. Otherwise, it will vote negative. And finally, if all the votes are positive, a committer can then submit the change so that it reaches the master branch. Then it will be merged on server side. So for commenting, you can directly comment inline in the source code, which is very convenient. So you can really have conversations on a certain line of code. And the result is typically that you have a couple of iterations, sometimes few, sometimes more, depending on the complexity of the change. So you really can follow this conversation through all these revisions. So there have been 17 iterations on this change before it was accepted. For the voting part, typically the code review, there are multiple categories you can vote on. Typically the code review category is used for the human review. So the other developers are looking at your change, and if they vote +2, the change is approved, so it can be submitted. If it's +1, okay, it looks good, but I don't want to decide. 0 is no opinion, of course. -1 is the most frequent one, so in general it's okay, but there are some tweaks which should be fixed. And -2 means it can't be submitted, so it's a veto. And similarly, there's another voting category, verified. This is typically done by Hudson. So if the build is okay and the tests are okay, it's +1, otherwise it's -1. And this is how the UI looks like. So if you open up a change in the review, finally you can vote here. And based on these votes, you can later on also submit the change if you're a committer. If you're a contributor, you will only see the range from +1 to -1, so you can give your opinion, but you can't decide. The basic idea behind Gerrit code review workflow is that every commit is reviewed separately. Of course, they can have dependencies. So if you implement a large feature, you maybe want to split that into multiple commits. But this dependency between these commits will be also respected by Gerrit. So we'll see one change in the review per commit you're pushing to the server. And then on each of these changes, you can iterate. So you get comments and you want to improve. So you amend this change, and then you push the amended change in order to react on the feedback. And the result is that only the last one, the newest revision of this change, can be submitted. So that you don't see all the zigzag you did during the review process. Maybe you did some mistakes and you fixed the mistakes, and you don't want to see that later on in the history. And by amending, you replace the previous revision. But all this is captured in the history in Gerrit, so you can still see what happened during the review process. How was this change improved? And the last one can then be submitted if it's okay. Okay, I skipped that one. And now a short demo, and then we are out of time. So I'll simply show, in the earlier exercises I showed how to create changes and how to rebase. So in this case we now have two changes. We have the multiply operation and the divide operation. And we already configured this repository to work with Git. So let's recap that. If you look here, the destination branch, that's now the magic Git does in order to generate review branches automatically. Typically, you push directly to a branch, and then the ref spec is named refs heads master, for example, if you directly push into the master branch. If you're using Git, you say refs for master, and this means push it into the review queue for the master branch. So if a change has passed the review, it will reach the master branch. If that's done, we can simply push these changes upstream. So it will use this configuration to decide where to push that. Everything up to date. This is funny. How did that happen? Okay, let's try a different dialog. Master. Don't know why this didn't work. Okay, it says now that there are two new changes on the Git server. So we can directly go there. And the main UI of Git is just a queue of changes which are in the review. So they are still open for review. And now we can inspect these changes. And there's a change screen which shows all the details about this change. So here on the right side you see the commit message. Here's some metadata. And here you see this change depends on another change which is also in review. This is what I mentioned when you're pushing changes, multiple changes which depend on each other, this will be recognized by Git. So you can see I also have to review this other change if I want to get this one in. And then you can see the changes which were done. So you can look at them in a side-by-side view, or you can also look at them in a unified view. I prefer that one because it's more compact. And then, for example, if you don't like this one, I mean, here's nothing to comment, but maybe in the other class. Okay, we could, for example, I recognize that here the copyright date is wrong. So I simply double-click this line I want to comment on. Save that. This is not yet immediately published, but it's a draft. And later on, when I publish the comments, the others will see that. Okay. This also seems wrong. Wrong Java doc. Okay, let's say this is enough for this review. And now in order to publish that, I press the review button. And now I can do this voting. So in this case, I would say -1 because I have something I want to see improved before I accept this change. And then I press the publish comments button, and then the guy who wrote that will get an email, or he can also go to this UI and see what's the status of his change. And then he can amend this change in order to fix what I commented on. And then you go through iterations until the reviewer is happy, and then the reviewer accepts this change. Maybe I show that on the other change, on the multiply branch. Let's review that shortly. So this looks okay. And let's say this is also okay, despite the fact that there's a wrong Java doc, but just to save some time, I ignore that now. So if I want to accept this change, I again vote here. Let's assume Hudson already did running the build and the tests, then Hudson would vote +1 on verified. And since I am okay with the content of this change, I vote +2, which is necessary to make it submittable. And now I publish my comments, and now you also can see in the overview that this change was accepted, but it's not yet submitted. Otherwise, it will disappear from this. So now I can, as I'm a committer, I can submit this change. And now it's merged, so it reached the master branch. And one more thing, if I now look at the list of open changes which are still in review, it's gone. It's no longer seen here. But if you go to the merge changes, you see what has been accepted. so you can understand what's happening on the project. And of course, I can also go to my local IDE, which doesn't yet know about this code review. So in order to get this information, I simply run fetch here. And then it updates what happened on the server. First of all, the master branch is moving because the change was submitted to the master branch. So the master branch moved. This is reflected now here because the origin master is now pointing at this new feature. And the other thing which happened is some summary of the review process was downloaded. And you can see that if you open this commit, which was accepted in code review, in the commit viewer, there's a new section here, notes, and this has a short summary of the review process. So you can see who voted who gave which votes and who submitted the change at which time. So you have some audit trail about the review process. And of course, you can still later on go to the Gerrit UI to see the full process with all the comments and so on, even 2 years later, because all the comments are captured in the Gerrit database. Okay, that's it for today. We ran out of time, so if you still have questions, I'm here for the full conference, so just approach me and ask your questions. Thank you.